Hello everybody, myself B. Suhas and I am from ITB, and my topic is Integrated Architecture IoT for Smart Metering. Abstract. The advanced metering infrastructures, that is AMI, are the systems that measure, collect and analyze utilities distribution and consumption and communicate with metering devices, either on a schedule or on request. That AMI are becoming a vital part of utilities distribution network and allow the development of smart cities. In this paper, we propose an integrated Internet of Things architecture for smart meter networks to be deployed in smart cities. It is shown the communication protocol, the data format, the data gathering procedure, and the decision systems based on big data treatment. The architecture includes electricity, water, and gas smart meters. Real measurements will show the benefit of the proposed IoT architecture for both the customers and the utility. Introduction. The integration of intelligent measuring devices in a city using Internet of Things, that is IoT, allows collecting all the data necessary to become a smart city. They are a fundamental part for keeping the city connected and informed, and ensure that each subsystem performs its function. The integration of information technology helps to control the subsystems that form the smart city. The installation of cutting-edge technologies and regarding measurements, communications and systems, network automation and disturbed generation, among others, facilitates the development of the city. The goal is to achieve a better management of the electrical energy, water and the gas providing networks, and an efficient balance between demand and consumption. A key technological element in this context is a smart meter, which can be a thing inside to IoT. A smart metering system allows the water, electric and gas utilities a continuous consumption, reading and recording in time intervals, or at least daily reporting, monitoring and billing. Smart meters enable two-way real-time communication between the meter and the utility central system. What are smart meters? A smart meter is a digital electronic device that collects information on electricity, water or gas use and sends it securely to the utility. These counters provide insights into consumption in real time to the utility and in some cases to the end user. In addition, these data allow understanding the spending habits, improving the network efficiency and contributing into electricity, water or gas saving. Thanks to the smart meters, the consumption data can be managed and impact on the network can be monitored in real time. Moreover, the location of meters often limits the signal transmission, meaning the lack of 100% real-time data. Sometimes there is a gap of hours or even days from the moment when the measurements are gathered from the meters and the moment when the information reaches the utility server. Real-time data from meters would allow synchronization with district metering areas meters and consequently the possibilities of making balances. This fact would dramatically reduce the response time in front of leaks, fraud and etc. And this is the diagram. Smart meter, energy, communications, data, and it's real-time alarms, costs and maintenance. You can observe it for a few seconds. Architecture and communication protocols. AMI systems include sensors, hardware, software, communications, consumption displays and controllers, customer systems, data mining software, metadata management software and business systems. They provide two-way communications with the meter, allowing sending commands from the utility to the smart meter for multiple purposes, including monitor real-time values and change the frequency of readings, among others. The network between the smart meters and the utility center allows collection and distribution of information to the customers, suppliers, utility companies and service providers. What is big data? Once the data has been gathered, it is very important to use the most powerful techniques to extract the most useful data. In this section, we describe some of the current systems to facilitate the process of treating high volume of data. Then we show our proposal to use the smart meters inside the IoT. Every big data system needs a processing infrastructure based on a cluster computing that has a distributed file system where the database is installed, allowing a concurrent programming model. One of the first systems was proposed by Google in 2004. It was based on a Google file system and it had a big table for the databases and a map reducers as the parallel execution model. Inspired on the Google solution, Hadoop appeared, which offers an open source solution with an Apache license. Since 2012, there is another open source alternative such as Apache Spark. Apache Spark doesn't define a cluster manager and a distributed source systems. It allows all the use of many different components. For example, Hadoop ecosystem can accommodate it. It uses Spark SQL as a database. Hadoop and Spark are the most used big data processing frameworks And we have chosen Spark especially because it integrates MLIB, Spark's machine learning library. Data collected from the electricity, water and gas smart meters using IoT can be used for many purposes. Those purposes drive us on how the data should be structured and prepared. Next goals are the most demanded by the utilities. Experimental results. So consumption patterns can be created with the data received from the smart meters. Different consumption patterns can be obtained from different users, companies and even geographical areas. With these patterns, the utilities are able to carry out the electricity, water or gas management studies. And these patterns can be used to create user profiles like the amount of time at sea, at meters, data billing, details, geolocation, address, incident record, leak, fraud, and unsupervised clustering machine learning predictor of consumption incident. So moreover, utilities would be able to detect water or gas leaks by means of the information received from the smart meters. Results from the data treatment. There are a number of advantages and benefits related to the smart meters, and to address the benefits derived from the installation of smart meters, we must differentiate between the benefits of the utilities and the benefits of the customers. The robbery of electricity, water and gas mainly to the utilities caused the increase of price to all the consumers. And for this, the consumption patterns are extracted and associated with customer profiles. Thus, personal consumption habits are obtained. When the customer habits change, an anomaly is detected, and this could be related to a fraud. Conclusion. And in this paper, we have proposed an integrated IoT architecture for electricity, water and gas smart metering. With the smart meters are things in internet. We have reviewed the main features of the smart meters technology. Our future work is focused on increasing the data set on the smart meters to be able to work with the more data taken at higher frequency and develop a robust protocol, IoT protocol, to support the amount of data. Thank you.